You have fallen into Event Horizon with John Michael Godier. In today's episode, John is joined by Professor Avi Loeb. Avi Loeb is the Frank B. Bird Junior Professor of Science at Harvard University, Chair of Harvard's Department of Astronomy, Founding Director of Harvard's Black Hole Initiative, and Director of the Institute for Theory and Computation within the Harvard-Smithsonian Center for Astrophysics. He also chairs the Advisory Committee for the Breakthrough Starshot Initiative, serves as the Science Theory Director for all initiatives of the Breakthrough Prize Foundation, as well as Chair of the Board on Physics and Astronomy of the National Academies. He is the author of 4 books and over 700 scientific papers. He is an elected Fellow of the American Academy of Arts and Sciences, the American Physical Society, and the International Academy of Astronautics. In 2012, Time selected Loeb as one of the 25 most influential people in space.
Dr. Avi Loeb, welcome back to the program.
Thanks for having me. It's a great pleasure.
Dr. Loeb, now we have a new interstellar object, I3 Atlas, and of course there's much mystery surrounding it and intrigue and a lot to learn. Learn with this thing. But the one...
Well, that's the nature of science. Science is fun because it's an opportunity to learn something new. And unfortunately, many practitioners of science prefer to rely on what they already know in interpreting new data.
You know, I think what intrigues me most, I want to get your view on this before we get into what I'm really interested in, which is intercepting it. But before we get into that, the age of this object, inferring based on its speed, its motion, which is much higher than Oumuamua was and Borisov, both suggesting, at least in a typical framework, that it is very, very old. That this is, whatever this material is, whatever its nature is 7 billion years old. Do you agree with that interpretation of this object's speed?
Well, I wrote a paper with my undergraduate student about that. And what we showed is if you extrapolate the trajectory of 3I Atlas, the new interstellar object discovered on July 1st, 2025, if you go back in time, you find that its trajectory within the Milky Way galaxy spans the range of heights above the midplane of the Milky Way galaxy that is associated with old stars. So it belongs to the thick disk of stars. If you just continue its trajectory back in time billions of years, you find that, it could have originated from an old star. This is not a direct measurement of the age. It's simply the fact that the velocity of this object is consistent with the thick disk of stars in the Milky Way galaxy. But just imagine that it was propelled by something else. For example, and we mentioned that in the concluding paragraph of our paper with my student Shokruz Kakarov, we say that any such object, if it was produced near a star, irrespective of the mechanism that made it, was associated with some ejection speed. Okay, so when you're saying the speed is high, therefore it belongs to the thick disk of stars, that ignores the ejection speed. If you were to eject it from a young star with a high speed, it would look just like 3I Atlas. So when people make reports to news reporters, about this object being old, that is assuming that the ejection speed was small relative to the speed that we measure for it. And therefore, it should have inherited a high speed that we often find in old stars. But it's not an age measurement. And also it assumes that the ejection speed was small. You have to keep that in mind. And not to speak about the possibility that it's not a natural object, which we will get to.
Oh, we will. But again, on the age thing, so simply because something is moving fast calls into question the very, very, actually almost stereotypical interpretation of the motion of objects in the universe, is that because it's moving fast, as you say, it inherits motion. And therefore, since it's moving fast and it's also been swinging around the galaxy for however long, getting gravitationally affected by everything, that speed means age. But no, it doesn't, because if you're sitting in a race car at the Indy 500 or something like that, well, it's going fast, but only because of its own volition, not its age. It was probably brand new, right?
Well, that's one way to look at it, but also imagine that the car has an ejection mechanism by which it can eject you out of the car at a very high speed, even if the car is not moving at all. How would you know from the speed by which you are moving whether it was a result of the ejection mechanism or the speed of your car? So the only way to say that it must be old is by assuming that the ejection speed from the original star was very small compared to 60 kilometers per second, the speed by which it entered the solar system. But we don't know that.
Can you have some weird dynamical thing, like a binary star system, for example, that could fling something out at much faster velocities than what we're assuming here?
Oh, yeah. So in fact, I wrote a scientific paper that was peer-reviewed, published, that suggests that the most likely ejection of interstellar objects is actually with this kind of a speed. And the mechanism was very simple. The most common stars are dwarf stars. They have about a tenth of the mass of the sun and a size about a tenth of the size of the sun. And that means that they are very dense because the mean density of a star would be the mass divided by its volume. The volume scales like the size cubed. And since the size is a tenth of that of the sun, the density of the most common stars is 100 times the average density of the sun. And it so happens that the average density of the sun is just below the density of rock. So if you take the Earth and bring it close to the sun, the tide, the gravitational tide from the sun will not be able to disrupt the Earth before it gets into the sun. However, if you take the Earth and bring it close to the most common type of stars, a dwarf star, the high density of the star would mean that as you bring it close to the surface of the star, the tide would be stronger than the self-gravity of the planet. And so what would happen is the Earth would be spaghettified. It will turn into a stream of molten rock. This half of the mass in this stream of spaghettified Earth, this is called the tidal disruption event. So half of the mass that is being disrupted by this process will get injected to interstellar space. And now when I realized that this mechanism could happen, I immediately calculated what is the ejection speed that you expect. Turns out that if you take the most common type of star and you take a planet like the Earth and spaghettify it close to that star, half of the mass of the planet will be ejected at, guess what, 60 kilometers per second. Exactly this speed. Now, the reason I wrote this paper was in reference to an interstellar meteor that was reported by the US government satellites back in 2014. And that one had roughly 60 kilometers per second relative to the local standard of rest of the Milky Way galaxy. So I wanted to find a mechanism, natural process that would give this high speed. And this is a very plausible scenario because I'm talking about the most common types of stars, and all you need is some rocky material to be sent close to the star. How can you get that? Well, if you have a giant planet like Jupiter and then it gives some push to the gravitational push to the rock in the direction of the star, that can happen because there is a mechanism that actually increases the eccentricity of an inner planet thanks to the existence of a giant planet outside of its orbit. And this mechanism would bring Earth mass planets close to dwarf stars, in which case you will get interstellar rocks flying at 60 kilometers per second. And now what would astronomers say? Well, if they see such a rock at 60 kilometers per second, they say, oh, it came from the thick disk. It must be very old. No, it can be young. and was ejected at that speed.
Need to really see the material, and we'll get to that in a minute. However, I want to ask a sort of oddball question. So we know of stars that have very, very high proper motion. It's in relativistic high proper motion, very fast moving stars due to interaction with supermassive black hole that flings them at extremely high speed. What is the upper end that you can envision for an interstellar object's speed? Could we see one much, much faster than the already fast 3I Atlas?
So here again, I published two scientific papers on stars that reach close to the speed of light as a result of them being near two supermassive black holes. So, where each galaxy has a supermassive black hole at its center, and when galaxies merge, and that is a common occurrence, that's how galaxies grow in mass, by mergers. So every characteristic time, which is a sizable fraction of the age of the universe, you get a merger. We will merge with, the Milky Way will merge with the Andromeda galaxy, that is our sister galaxy next door, within a few billion years. And the point is that when two galaxies like that merge, the black holes at the centers come together and they form a pair that tightens up as a result of dynamical friction on the background stars and gas. And eventually the two black holes might come close to each other. And the stars that are in between the black holes can be ejected at a speed of up to the speed of light if the pair of black holes is relatively tight. And so I calculated in two papers that were published about a decade ago, what would we expect for the population of relativistic stars in the universe? Because these stars will definitely escape from their host galaxy and will fill up the intergalactic medium, the medium in between galaxies. And so there is a population of stars moving at up to the speed of light, if you can believe it, right now through the universe that originated from black hole mergers at the centers of galaxies. And I calculated the population, how many of them do we expect per unit volume, and concluded that it would be really difficult to detect them because, it's difficult to detect a single star, even if it's bright, at intergalactic distances. But if you are living on a planet close to such a star, and you are ejected with the star at close to the speed of light, that would make an amazing journey through the universe because you will cross your own galaxy within, tens of thousands of years, and then you will get to intergalactic space and you could see other galaxies along the path. That's the best way to take a trip at close to the speed of light that I can imagine. It would be very difficult to construct a spacecraft that reaches the speed of light, but nature does it for stars that happen to be close to a binary black hole system.
Dr. Loeb, what occurs to me is perhaps something very apocalyptic. When you have two galaxies like Andromeda and the Milky Way merging, and those two black holes come together. Now, in a binary star system, a very close binary star system, they can rob each other of energy. They can rob each other of gases. They can distort into ovals towards each other. Can you do that with the event horizon of a supermassive black hole when you get two of them nearby each other, pulling on each other? Can the event horizon not be a perfect sphere?
Oh, definitely. It gets distorted, and eventually the two event horizons join. And then they obtain an area that is bigger than the sum of the areas of the two. The fact that black hole mergers lead to a sum of the areas that is bigger than that it leads to a total area that is bigger than the sum of the areas of the two black holes was a result obtained by Stephen Hawking in the 1960s. And based on that theorem that he derived, Jacob Bekenstein suggested he was a PhD student at Princeton, and he suggested that maybe black holes have entropy because that reminded him of the fact that entropy always increases according to the second law of thermodynamics. And his mentor, John Wheeler, said that the idea is crazy enough to be correct. And then Stephen Hawking heard about the conjecture that Jacob Bekenstein made, and he said, that makes no sense, and I will prove it wrong. So he started to do quantum mechanical calculations to demonstrate that black holes do not have entropy. And when he got the results, he realized actually they do. And because of that, they have a temperature. They have entropy and temperature, and they radiate radiation. And as they lose mass or lose energy, they eventually become smaller, and then they evaporate even faster. And they explode. They disappear. This is called now Hawking radiation, and it's the most important scientific result derived by Stephen Hawking. For astrophysical black holes, the evaporation time is completely negligible. It's much, much bigger than the age of the universe. The only black holes that can evaporate during the age of the universe, have a mass that is smaller than 3I Atlas, the new interstellar object. They need to have a mass of the order of a few times 10 to the 14 grams. And that is the mass of an asteroid that has a size of just a fraction of a kilometer. Such black holes, if they were made in the Big Bang, would show Hawking evaporation. So astronomers looked for any radiation that could have been emitted by exploding black holes. We haven't seen any. But it's possible that the dark matter in the universe is made of primordial black holes that are more massive than this limit, so they didn't disappear. They still exist, but they continue to evaporate, so we can search for the radiation coming from them. Just to give you a sense, if we are dealing with a temperature, a Hawking temperature of about that of the sun, the surface of the sun, we are talking about a black hole that has a mass that is quite large, similar to that of the moon. And the amount of luminosity that such a black hole produces is around, tens of nanowatts. It's tiny. As you make the black hole smaller, then the luminosity gets higher, and eventually you get it to explode in a gamma ray flash. But we haven't seen any such flashes. Even if the dark matter is made of those primordial black holes, we didn't see any signature of them. And there is a range of such black holes in the asteroid mass range that is still allowed. It's not ruled out by existing data. And so it's possible that the dark matter is made of primordial black holes. And if so, we could potentially sometime in the future detect the Hawking radiation from these black holes.
It would be one of the more elegant answers to what is dark matter, because other than that, it's a particle or something like that, or something that we don't understand at all. So it just starts going further and further out there. But at least...
you are correct that in principle, it's a very simple solution. The problem is, how do you make them? And what you need is, that within the horizon of the universe early on, the horizon is the distance that the light traveled since the Big Bang. So when you go back in time, that age of the universe was smaller and smaller as you approach the Big Bang. And if within the volume associated with the cosmic horizon, you have a mass density or energy density of radiation that exceeds a critical value, then that region would collapse upon itself to make a black hole. But as of now, all evidence indicates that the kind of inhomogeneities that existed in the early universe were at the level of 1 part in 100,000. And what you need to do here is enhance them to a level of order unity in order for primordial black holes to happen, so to be produced. And this kind of enhancement is not easily arranged. You don't want to make it easy, because then you will convert all the mass content of the universe into those primordial black holes, and we don't see that. I mean, we know that the cosmic microwave background dominated the mass budget early on in the universe. So we want to convert a tiny bit of the radiation into black holes, but then it becomes a problem of fine-tuning. How do you arrange for a process that will just make the amount of dark matter that we need, but not overshoot and produce much more than that? And it's not easy to arrange for that. We don't know of a process that will do that. And so I would argue that actually some elementary particle being the dark matter is a more plausible explanation.
So a weakly interacting massive particle, essentially the WIMP.
Well, that was so since I started astrophysics 40 years ago, that was the popular view that the dark matter may be a weakly interacting massive particle, and in particular, the lightest supersymmetric particle. Supersymmetry is a new symmetry of nature that was proposed, and people thought it's very natural, and various ideas that were floated about it gave whoever proposed these ideas honors, awards, and recognition. And everyone said, yeah, it probably exists, and the dark matter is the lightest supersymmetric particle that cannot decay into anything else because it must be stable if it's the lightest. And then the Large Hadron Collider searched for supersymmetry in the natural range of parameters and didn't find it. And it didn't find dark matter either. There was no particle detected that could account for dark matter. And, that is something really fundamental about science that you have to understand, that, irrespective of what is the popular view of the mainstream is wrong very often. And the only way for us to figure it out is by collecting data that will test our ideas. Now, it sounds like common sense, straightforward. Of course, we need data to check our ideas because the range of possibilities is far greater than the one possibility that is realized in nature. I could have had $1 trillion in the bank. I could have had $1 billion in the bank. I could have had many different amounts of money in the bank, but I do have a very specific value, and I have to build my lifestyle based on that. And so, of course, it could have been the case that supersymmetry existed in the natural range of parameters, but reality may not respect that, may not satisfy this symmetry. So it doesn't matter how many likes an idea gets on social media or within the mainstream of science. It is the guillotine of experiments that chops the head of ideas that are not describing nature. And that has to be respected. Now, why do I say has to be? Is because the mainstream of theoretical particle physics for the last 40 years, since the time I started astrophysics, had a very popular theory called string theory, imagining that there are extra dimensions and we can unify quantum mechanics and gravity if we just follow the math. And after 40 years, the math did not bring us to a unique theory that makes predictions that can be tested by experiments. And so that violates the very fabric of scientific knowledge, where we test ideas by experiments, and if an idea cannot be tested, then we cannot really know whether it's real or not, and therefore we are left in the dark. So you can work for 40 years on a mathematical idea and demonstrate that you are smart. It's sort of like doing intellectual gymnastics. But if you really want to discover something about nature, you need to seek the contact with experimental data, because without it, you're doing mathematics, you're not doing physics.
It reminds me, speaking of revising one's priors and revision, it's the steady state universe. There were physicists that worked their entire career based on the steady state model of the universe. And I believe certain ones like Fred Hoyle never did give up on it and was trying to argue it till the end that, there had been no Big Bang.
Yeah, well,
and now clearly this is not the case.
It's not the case. And, it's really important to recognize when the data does not support your theory to back off your theory. I mean, that was the big mistake of the Vatican, when Galileo Galilei looked through his telescope and said, well, I see these moons around Jupiter, and it implies that not everything revolves around the Earth. Now, the Vatican said, we don't want to hear you. We don't want the public to hear you. We will put you in house arrest. If instead they would have said, okay, that's what you say, but we will build a better telescope, look at the sky, and prove you wrong. If they adopted that strategy of saying, we believe that you are wrong and we will show it by collecting better data, then they would have corrected course very quickly. Instead, what happened is, 350 years after Galileo died, they announced in 1992 that he was right. And that was very embarrassing, because it was 20 years after humans landed on the moon. So they couldn't really deny the fact that when you look at Earth, it moves around the sun. You can see it from a distance, from spacecraft. And what's the lesson from this? The lesson is that once you have good enough data, you should back off. And the best way to decide about wrong or right ideas is not by arguing that, I did very fancy mathematics to prove the point, or that I'm very smart. That is not really something respected by nature. The Earth revolved around the sun for 4.5 billion years before the Vatican even existed. And it continued to revolve around the sun after the Vatican said no to Galileo. It doesn't really matter what people on Earth say. They can fool themselves. They can be sure that they are the smartest in the universe, while they have a neighbor that is smarter than them. They can ignore that possibility. And, it's a self-fulfilling prophecy. If you're not seeking data, you will never show yourself wrong. And of course, that is the strategy adopted by the Vatican at the time of Galileo. But it's not a good strategy in the long term, because someone else will get more data. Eventually, humans go to space and they see that the Earth revolves around the sun. So what are you trying to prove? I mean, in 1992, you have to say, I was wrong, Galileo was right, okay? So you are just delaying the rate by which humanity is gaining knowledge about its physical environment. We either have a neighbor or we don't have a neighbor that is intelligent as we are or even smarter. It has nothing to do with what we say within our home to our family. We can ridicule the notion that we have neighbors. We can look at many houses on the street and claim that they have only microbes, which is pretty much the opinion of the mainstream of astronomy right now. The highest priority is to build the next generation space telescope, the Habitable World Observatory, that will search for the molecular fingerprints of microbes. And that will be at a cost of more than $10 billion. At the same time, no priority is assigned to funding the search for intelligent beings out there. And the argument is, imagining that these houses on the cosmic street that are just Earth-Sun analogs, and there should be billions of them in the Milky Way galaxy alone, these billions of houses only have microbes. We don't know. It's an extraordinary claim to imagine that something like us exists as a resident in those houses. And therefore, we should invest in looking for microbes, because microbes must be much more abundant. But good luck if you want to look through your window and search for microbes in other houses on your street. That is a very challenging task. However, if you have a neighbor, that neighbor might come to your front door, or that neighbor will construct something in the backyard that you can see from a distance, or you will get a tennis ball that was thrown by a neighbor. In all these examples, or you get a package in your mailbox, that's another possibility. In all these examples, the signature is very clear. Even though intelligent residents might be much fewer than microbes in this street, you will have an easier time to find them. And all I'm saying is, we should hedge our bets. It's easier to find intelligent beings than it is to find microbes. Microbes might be much more abundant. We should do both searches with comparable level of funding, because we don't know where the discovery will come from. And we should be open-minded to the possibility of discovering intelligence beyond Earth, because it may be out there. If we make it heresy to discuss that possibility, then we will just maintain our ignorance. But it doesn't mean anything for our cosmic environment. It will still exist.
My reaction in 1992 to the Vatican's apology to Galileo was, you people have been running serious astronomical telescopes and experiments for a century. The Pope has 2 observatory domes on his palace at Castle Gandolfo, and you're just now getting to this? You would think.
Yeah, I mean,
you would think that they would have been a little bit more efficient on the apology.
But this is not my only concern. I'm looking at science, and I'm really concerned that there is a lot of resistance to thinking outside the box, to walking outside the beaten path. I bring it up in the context of the search for intelligent life elsewhere beyond Earth, because, when young scholars, students, fledgling scientists are looking at the response of senior members of the academic community to a discussion about this subject, they are really afraid of going in that direction because they're worried about their prospects for jobs. And that suppresses innovation in science. That's the best recipe for maintaining our ignorance. And the public really cares about this question. It will change the future of humanity if we find another civilization as intelligent or more intelligent than we are, because they may know better physics. By the way, it will give us a shortcut to resolving questions of how to unify quantum mechanics and gravity. They may know the answer. It may feel like cheating in an exam if we find them without us finding the answer ourselves. But if it saves us a lot of time, we just had 1 century of modern science and technologies since the discovery of quantum mechanics and the general theory of relativity. So they may have had much more time. They may have had bigger brains that allow them to make progress much faster than we do. So altogether, it's an opportunity for us to grow. And also noticing them may bring people together, because we would feel that we, as members of humanity, are all in the same boat, the Earth, and there is someone else out there. And so we shouldn't fight each other, kill each other over territories here on Earth, because there is much more real estate in interstellar space. It's really narrow-minded of us. It's like kids fighting in a sandbox and then realizing an adult comes to the scene and they stop fighting and realizing, wow, there is something beyond this sandbox that we are fighting on. And, that could be really an opening chapter in the future evolution of humanity. I see that as extremely important. So then, just like the wager that Blaise Pascal, the mathematician philosopher, made, he said that we don't know if God exists or not, but the implications would be huge if God exists. And therefore, we should consider that possibility. And I say the same thing about aliens. I say the implications would be huge. We cannot dismiss that possibility without collecting data, without following the scientific method. And by the way, the scientific method, that is often missed by not just some people in the public, but actually professionals practicing science. They miss the point. They ban discussion on some questions. The scientific method is all about allowing all questions. You can ask any question you want. You can think about any possibility you want. But the way to resolve whether that possibility applies to nature is by collecting data and ruling it out or ruling it in. It's just like a detective operates. So for that, you need to get experimental data. So you better ask questions that can be addressed by experiments. If you just spend 40 years on mathematical gymnastics without any contact with experiments, you're not really following the scientific method. You want to check whether you are going on the right path. It's sort of like, taking a herd of people with you, shepherding it and leading it along a path and saying, this is the right path. But if it turns out to be the wrong path, because nature has nothing to do with the idea, the direction that you're taking, you can take the entire herd with you and you will be misguiding them. However, if you allow some members of your herd to examine other paths, other roads that were not taken, they might actually find the correct path that leads you to the resolution of how to unify quantum mechanics and gravity. So in the context of science, we should not limit the questions being asked in general or any conjectures we make. We should focus on those that can be tested experimentally. But the scientific method is about figuring out which option is the correct one based on data. And that requires investing time and money in the search for the data. So you can't just say it's an extraordinary claim to imagine something like us and then put zero funding federally to the search for extraterrestrial intelligence. That makes no sense because you didn't allow for this possibility to be falsified. So how do you know? If you didn't seek the evidence, how do you know that it's extraordinary? You don't know because you didn't put money into it. So let's put equal amount of money in the search for microbes and the search for intelligence. And then we can say something after a decade or 2 decades. And, if we don't find anything, we will not be at any different place than those people who argue that supersymmetry exists or that the dark matter is the lightest supersymmetric particle. They were wrong. We invested the money, we didn't find it. Nobody blames them. That's the way science is done. But claiming that it's an extraordinary claim to imagine that there is something like us or better out there, I think, without funding it, is non-scientific.
I think the problem is that there's a bias, and we see that with back in 1993. NASA actually had funding for a time, very short time, for SETI research, radio SETI, looking especially for a signal from alien intelligence out there somewhere. And it became political, and a congressman got the funding canceled, talking about little green men and all of this and how it was waste of money.
I know the history. Yeah, this history is really irrelevant because we are now so many decades after that. And my point is simple, that the search for radio signals is just like you say, okay, on the cosmic street, I may have neighbors, and let me wait for a phone call from one of them. So you are waiting for a radio signal that will communicate a message to you, just like as if you were waiting for a phone call. You are a passive observer, just waiting. And nobody may call you when you are waiting. It so happens that nobody from my street is calling me. Since I moved to my street 20 years ago, nobody from the street called me. I really see those people when I walk on the street and I say hello to them. But they don't call me at home because they're so close to me. However, a very different approach is to search maybe for a tennis ball that came from a neighbor's yard. I do find those. Just yesterday I found a ball in my backyard from a neighbor. So not everything that comes into my yard is made of rocky material, the type of objects that I see in my backyard. Every now and then there is a tennis ball, and it's not made of rock. Okay? Now, what is the situation with objects that enter the solar system, our cosmic neighborhood? The situation is that whenever we see an interstellar object that arrived from outside the solar system, the experts on asteroids or comets say it must be a comet. So, for example, Oumuamua, the first interstellar object, had no gas or dust detected around it, the way you see in a coma or a cometary tail around comets. So there was nothing around it. Yet now the experts call it a dark comet, which means there is a cometary tail, you just can't see it, it's invisible. And just to inform the conversation, this object, Oumuamua, that was discovered in 2017, had to lose about 10% of its mass in order to be propelled with non-gravitational acceleration that was detected for it. 10% of its mass. I'm not talking about a tiny bit of material. So they say that this 10% of the mass is invisible, even though the object itself was visible. So I feel as if I'm the kid in Hans Christian Andersen's tale saying the emperor has no clothes. I don't see any clothes. And then the adults in the room tell me, oh no, the clothes are invisible. And this is the mainstream view. Can you believe it? The mainstream argues that something exists that cannot be seen, that makes it a comet, a very visible conventional object. Now, it's just like saying that an elephant is a zebra without stripes. Okay? You would say, okay, stripes define a zebra. I see here an animal that doesn't have stripes. I call it a zebra without stripes. Why is that misleading? It's misleading for a simple reason that, for example, on January 2nd, 2025, this year, there was a near-Earth object. It was classified by the Minor Planet Center as a near-Earth asteroid, a rock. And then within a day, they realized that the path of this object follows the trajectory of the Tesla Roadster car that was launched in 2018 by SpaceX. So they immediately removed it from their catalog. Why? Because they knew about the Tesla Roadster car. This was not a rock, it was a car. And my point is, just imagine that Elon Musk is not the most accomplished space entrepreneur since the Big Bang. 13.8 billion years ago, and that there are interstellar cars. In that case, we would not know that it's not a rock because we don't have access to the trajectory that this interstellar car was launched in. So we would say it's a comet without a visible tail, or it's a rock. And when astronomers would say that, they would have no hesitation. But yet what I'm trying to argue is we need more data to figure out the nature of an object. Now, I defined a new scale a month ago that is now called the Loeb scale. There is actually a paper about it in the Astrophysics Archive, where 0 means a natural interstellar object, where we can see the cometary tail, or we can definitely infer that it's an icy rock for some other reason. And 10 on that scale is a definitely technological object that we can tell because it maneuvers, or it broadcasts a message, or it emits some artificial lights. It has a light source in it. It's not just reflecting sunlight. And I define also all the numbers on this scale between 0 and 10. I suggested that Oumuamua, the object I was talking about, has a rank of 4. And the same is true also for 3I Atlas, a rank of 4. Now, once we see a clear technological signature, then it will go up the scale. But if we see a clear natural signature, it will go down the scale. Science is a learning experience, and I would revise my rank based on the data. And of course, we might learn more about this new interstellar object, 3I Atlas, discovered in July 2025 by a half-a-meter telescope in Chile called Atlas, which happens to be, by the way, a neighbor of the Rubin Observatory that was inaugurated in June 2025. And the Rubin team was able to find this new object, 3I Atlas, in the weeks preceding the discovery announcement. And so this small telescope scooped the Rubin telescope, which is 8.4 meters in diameter, with a camera of 3.2 gigapixels that will survey the southern sky every 4 nights, and actually could discover, based on expectations, an interstellar object every few months. And so this opens a new era where we will have a lot of interstellar objects, several dozens of them in the coming decade. And we could then ask the question, what is the rank of each of them on the Loeb scale between 0 and 10? And if any of them ends up being technological, this would be of great importance, because if it's a functional device, the question is there any threat to Earth? Because we are always talking about the existential threat from artificial intelligence, from global climate change, or from an asteroid impacting the Earth. We don't talk about alien technology. And it's very different from an asteroid, because in the case of an asteroid, there is this planetary defense office at NASA that is monitoring objects that may come close to Earth. And the idea is that once you know the trajectory, the orbital parameters, you can calculate whether they will hit the Earth anytime soon. And that's just following the laws of gravity. However, if you have a technological object, then it could maneuver. It doesn't follow just gravity, and it could pursue some task. So the defense against that is very different. And in the future, I'm not expecting anything to be done immediately until we will have clear evidence for a technological object ranked 10 on the Loeb scale. And then, of course, this would be a wake-up call. And we would immediately establish an international organization that includes people from all countries, because, the aliens do not really care about how we split territories on Earth. And whatever happens at one location on Earth could happen shortly afterwards at another location. So all humans should come together. No country, no nation should use this encounter to harm another nation. And based on all available data that one needs to collect with all telescopes, all assets in space that we have, those that are used for national security should be retasked to look at whatever technological object is visiting us. And based on that information, policymakers will decide about how to respond to it. You cannot decide ahead of time because you need to know the details. What we can imagine in terms of technologies is limited to our experience. And as I said, what comes from another star is a whole new ballgame. It could represent technologies that we've never imagined. Not even producers of science fiction films in Hollywood imagined, and because it goes beyond the science and technology that we know about. So we will have to respond depending on the qualities and the intent of the visitor. I believe that this will change the future of humanity, because after we have such an encounter, there will be questions asked about future encounters. And, we will have to put perhaps an array of spacecraft within the solar system that monitors the solar system for any incoming objects and alerts the Earth for any technological object that may be coming our way. We might need to come up with an interception policy of what to do if there is an imminent threat, whether to use nuclear weapons or not, or whether to always welcome whoever comes to visit us. It's just like, imagine having a person in your backyard and you are consulting with your family members what to do about this person. It's not like getting a radio signal or getting a phone call. In case we get a radio signal from a source that is thousands of light years away, we have plenty of time to decide what to do about it. We don't need to worry about an imminent threat. But in the case of a visitor in our backyard, that visitor may come through the front door. You have to decide immediately what to do about it. And that is a completely different situation. All of this is to say that what the SETI community did in the past, which is waiting for a phone call or trying to detect a radio signal, is very different from what can be done, which is detecting interstellar objects and checking whether any of them is technological. Because if that happens to be the case for one of them, it will change the way we think about space. It will change our aspirations for space. We might decide to visit other stars. It will change everything. It will change, if, for example, this new object 3I Atlas, as it comes closest to the sun on October 29th, 2025, if it maneuvers and takes advantage of a gravitational assist from the sun, the way our spacecraft often do. So in that case, if it wants to brake, it can actually do it most effectively closest to the sun. By the way, we won't be able to see it because the Earth would be on the opposite side of this object 3I Atlas when it comes closest to the sun on October 29th. But if we don't see it coming from the other side the way we expect, the stock market may crash.
Let me ask you this before we get directly into 3I Atlas and how we actually can observe it when it's behind the sun from Earth's perspective, but we have other spacecraft out there. But before we get to that, what are the statistical implications of turning on the Vera-Rubin telescope and doing the surveys, which it promises to catch many interstellar objects so that we'll have a robust population to study, in coming years. But what happens if, because, back during the days of Oumuamua's passing, we, there were all kinds of ideas out there, and we talked about many of them in past shows. But you should be, given that it was the first thing we saw, and it was weird, and you pointed all of that out. It was weird. But we should see a lot of those. What happens if the Vera-Rubin telescope fails to pick up any further objects like Oumuamua that have that strange
that would
of a group
enhance
of
the
characteristics?
mystery.
What would that mean?
Why did we see it only once? Of course, for natural objects, you can do the statistics and you say, okay, I looked at the sky with these sensitivities for a period of 1 decade. I found one object. Then I'm very likely to find more of the same in the coming decades. It's just simple statistics. Now, it doesn't mean that you definitely have to find. But if you have an instrument with better sensitivity so that you can look for objects across a bigger volume, then the number of objects you will find will scale as the volume that is being surveyed for objects on random trajectories. There is no way out of that. And the Rubin Observatory is much more capable than the Pan-STARRS telescope that discovered Oumuamua. And if it doesn't find, given its bigger sensitivity, bigger survey volume, it doesn't find any Oumuamua-like objects, that would make Oumuamua even more peculiar than it was. I should just mention that it was spinning or tumbling every 8 hours, and the amount of sunlight reflected from it changed by a factor of 10 as it was tumbling. And there is a detailed paper that was attempting to make a model for the shape of Oumuamua, and the best fit model at the 92% confidence was that of a pancake-shaped object, a flat disc-like object. So it wasn't just strange because it had non-gravitational acceleration, but it was strange in terms of its shape. And I'm just saying, when something looks strange, let's admit it. Let's not say there is a cometary tail, but we can't see it, it's invisible because this object is made of hydrogen, nitrogen. We've never seen any icebergs made of hydrogen or nitrogen. If the first interstellar object we see is behaving so strangely, it must be very common. So my point is, let's maintain our curiosity. Let's keep it alive. And, rather than shove all the anomalies under the carpet of traditional thinking. And to my surprise, practitioners, especially the SETI community, I should say, there are members of the SETI community that are violently opposed to considering Oumuamua or 3I Atlas being anything other than a comet or an asteroid. They are violently opposed to discussing that possibility, and they insist that the only thing we should do in the context of searching for intelligent civilizations is search for electromagnetic signals from far away. And I simply don't understand that, because people who search for dark matter, there are different proposals for what dark matter is. We mentioned 2 of them. One was weakly interacting massive particles. Another one was primordial black holes. I've never, I went to many conferences on the nature of dark matter. I never heard the group of people advocating for primordial black holes saying, we don't want to listen, we don't want any talks in our conference on the possibility that dark matter is made of weakly interacting massive particles. I've never heard that. However, the SETI community decided, as a rule, not to discuss objects near Earth in their conferences. There are unidentified anomalous phenomena that are objects not identified. We don't know what their nature is. That subject is banned from SETI conferences.
Well, do you think there is a deep-seated ontological fear or fear of ontological shock by finding that an alien civilization was closer than you thought it could be? Now, people will cite all kinds of statistics and say, well, what are the chances of having one right next to you or something like that? But we don't know what the rules are. We don't know what aliens do.
Exactly.
And we wouldn't know.
Yeah, exactly. It really, so let me illustrate that with 3I Atlas, okay? So when 3I Atlas was discovered and was announced, that night I had to wake up at 2 a.m. because I was speaking on Coast to Coast. And one of the listeners emailed me about this object. And as soon as I learned about its brightness, I calculated how big, if it's a solid object, how big it could be. And I found that it needs to be 20 kilometers in diameter in order to reflect enough sunlight for a typical reflectance coefficient, albedo, of 5% that is often observed for rocks, for asteroids. And a 20 kilometer is huge. It's bigger than Manhattan Island. It's twice the size of the asteroid that killed the non-avian dinosaurs 66 million years ago. And, there should be 100,000 objects like Oumuamua. If Oumuamua and 3I Atlas are both rocks, and we judge by what we find in the solar system, in the main asteroid belt, you would expect 100,000 objects like Oumuamua for any one that is 20 kilometers in diameter, like 3I Atlas. And we haven't seen 100,000 Oumuamuas before we saw 3I Atlas. There was Oumuamua, Then there was Borisov, and now 3i Atlas. That's it. So that was very puzzling to me. On the 4th of July, just a few days later, my wife wanted us to go on a vacation, and I, of course, could not take the time off because I wrote a paper saying, it's not just the number puzzle, it's also if you calculate how much rocky material should exist in interstellar space per unit volume, and then you package all of it in 20-kilometer sized rocks. So imagine all the interstellar rocky material is arranged into rocks of size 20 kilometers. Then you should get one of those per tens of thousands of years in the inner solar system. And we surveyed the sky only for a decade, and we found 3i Atlas. So it can't be that it's a 20-kilometer rock. There is not enough rocky material in interstellar space to give it to us once per decade. And I'm talking about a discrepancy by orders of magnitude, not a factor of 2.
Yeah, no, it would be centuries.
Yeah.
You would only see that big every
millennia,
1,000 years,
10 millennia.
Yeah.
So the last time such an object came would be before humans documented their history, like 10,000 years ago. That's if you make the optimistic assumption of packaging all of the rocky material in such objects. So I said, that makes no sense. So of course, one possibility that I suggested in my paper was to say, actually, the nucleus of this object is much smaller, less than a kilometer, and it's surrounded by a cloud of dust which reflects sunlight. So what we are seeing is mostly the light reflected by this cloud of dust, the way comets look. And then I had a concluding sentence. The alternative is that this object targeted the inner solar system by design. And the editor wrote to me, "We will publish your paper as long as you remove this last sentence." And I thought to myself, amazing, isn't it? That just one sentence in a paper makes the editor upset to the level that he will not accept my paper for publication unless I remove the possibility that it might be technological and it's targeting the inner solar system. But, the rebel that I am, because of that experience, I decided to write a full paper on the possibility that it might be technological. So at the end, it was not one sentence, it was a full paper that was published afterwards with my colleagues, Adam Hibberd and Adam Crowell from the Initiative for Interstellar Studies. In that paper, in addition to the argument I made about, the object cannot be that large, and if it's not a comet, it could be technological, that because it targeted the inner solar system. So its arrival into the inner solar system has nothing to do with the rocky material in interstellar space, has nothing to do with that reservoir because it targeted the inner solar system. Now, it turns out that the trajectory of 3i Atlas is very fine-tuned, completely consistent with this notion. It actually lies in the plane of the planets around the sun to within 5 degrees. There is an illustrator that shows in 3 dimensions the trajectory of 3i Atlas. And what you see is an object coming from very large distance, and it's aligned with the planets. Now, the chance of that happening at random is 1 in 500. But suppose you say, okay, miracles occur. Every now and then you have something very unlikely happening. You say, okay, I accept this trajectory. It's not designed, it's in the plane of the planets by chance. But then you can play with the arrival time. It turns out that the arrival time along this path is also very fine-tuned. You just look at the orbits of Mars, Venus, and Jupiter around the sun. These planets are moving around the sun, around and around and around. This object, 3i Atlas, is getting very close to all 3 of them. And the chance of that happening with a random arrival time is 1 in 20,000. So I said, whoa, wait a minute. Could this trajectory represent a design that is intending to pass close to these planets and, for example, release mini probes that will visit those planets or do a reconnaissance mission? The second thought that I had is, this is great. It will come close to Mars. We have some orbiters, some spacecraft near Mars that can look at it. There is a 0.5 meter camera HiRISE that can look at it. And I actually communicated with the research team of that camera just yesterday, encouraging them to look at 3i Atlas when it comes close to March on the 3rd of October, 2025. On March 16th, 2026, 3i Atlas will come close to Jupiter. And there is a spacecraft called Juno that was launched in 2011. It was doomed to crash into Jupiter in mid-September 2025. So I wrote a paper saying, let's not push it into Jupiter, let's push it away from Jupiter so that it will come close to the path of 3i Atlas and can rendezvous it, basically come close to it, maybe intercept it or just come close to it, depending on how much fuel it has. And we calculated in the paper how close it can get to the path of 3i Atlas in mid-March 2026, depending on how much fuel it has. And even with 10% of the initial fuel that it had, it could come within 25 million kilometers of 3i Atlas. If it had the original fuel reservoir, it could have intercepted it.
Well,
So
you
a day-
calculated, though. You calculated based on its fuel usage. You got an estimate, right?
Yeah.
That it actually has a fair amount of fuel left, right?
Well, I spoke also with the team of Juno and asked them to estimate how much fuel they have. But just a day after I submitted my paper for publication, I got a phone call from Congresswoman Anna Paulina Luna, and she wanted to get an update about 3i Atlas from me. And I mentioned this paper to her, and she volunteered to write a letter to the head of NASA, encouraging NASA to look into the possibility of using Juno to probe 3i Atlas. And I'm really grateful for her vision. But overall, this object 3i Atlas is described as a comet by the comet experts. It came from the direction of the center of the Milky Way galaxy, which is very crowded in stars. And that may be a good reason to come from there if you don't want to be identified early. That's why we discovered it only in July 2025. It also moves on a retrograde orbit, which means that if it sheds any mini probes, they would move opposite to the direction of motion of the planet, so they can easily meet a planet along its path around the sun. It doesn't need to chase the planet. So a retrograde orbit aligned with the plane of the planets around the sun, was the most unusual thing that I realized that this object possesses. And now the question of whether it's a comet, first of all, there were several teams that tried to detect the signature of gas around it, and they couldn't find the spectral fingerprints of any molecules, carbon-based molecules or oxygen atoms that are often found around comets. And then there was the best image that was obtained was taken with the Hubble Space Telescope. And in that image, we see a relatively compact glow of light around 3i Atlas that extends out to 10,000 kilometers. And it looks like a coma that is often associated with comets, but it leads the object. It's in front of the object. There is no evidence for cometary tail behind it. Now, the spectrum of this object, 3i Atlas, is reddened. We see reflected sunlight that is reddened. Of course, to get it from dust that is outflowing from a comet, you need dust particles that are roughly of the size of the wavelength of sunlight that is being reflected or reddened. But if they are a fraction of a micron, half a micron, the wavelength of visible light, then the radiation pressure from the sun would push them within a day, I calculated, to trail 3i Atlas. And so we should have seen a tail that is very often seen around comets. And so we don't see that. We don't see a bright tail of dust particles that are doing the reddening behind the object. And the question is why? And another mystery is, in the analysis paper of the Hubble image, there is a plot, figure 3, that shows the brightness profile around the nucleus. And projected on the sky, what you see is that the brightness scales inversely with angular separation from the nucleus to the third power. This is much steeper, a much steeper brightness profile than found for comets. Usually what you see is 1 over the angular separation, which you can understand because if there is an outflow, a steady outflow of dust from a comet, then the density of the dust will fall off inversely with distance squared. And then in projection, it would appear like the brightness falls off inversely with distance. So that's very often found around comets. In this case, it was 1 over angular separation cubed. So that means in real space, the brightness falls off inversely with distance to the 4th power. So how can you get that? Well, if you have an outflow of dust where the density declines inversely with distance squared, and you have a central source of light where the flux falls off as 1 over distance squared, then the combination of the two, if you scatter the light coming from the central source by the outflowing dust, you will get 1 over distance to the 4th power. So is 3I Atlas generating its own light, or is it reflecting sunlight? This is a question that I'm trying to address in my next paper. These are interesting questions. There is an anomaly about the brightness profile of this object. There is an anomaly about, the fine-tuned trajectory of this object. There is an anomaly of not seeing a cometary tail behind it. And I'm just saying, let's continue to monitor it. Because if it's a comet, then it would get warmed up as it comes closer to the sun. And we should see it erupting in volatiles, in dust particles, in gas. And we should see a beautiful cometary tail behind it. But if it's something else, we will not see that. And so we shouldn't prematurely announce that it's a comet like the ones we know about in the solar system. That was the case for 2I Borisov, which looked very similar to comets that we are familiar with. This one does not look like 2I Borisov at the same separation from the sun, roughly. So let's continue to monitor it and figure out whether it's a 0 on the Loeb scale or maybe a 10 on the Loeb scale.
Now, with this object, I have 2 questions. And the first is okay, it's passing somewhat near 3 planets in the star system, but it had an opportunity, had it been launched earlier from a different angle, to take advantage of something like, I don't know, the Grand Tour arrangement of the 1970s and 80s, where you were able to, if you were coming in from outside of the solar system, you could have hit closely a number of the inner planets and then had all of the outer planets aligned. If you're going at these sorts of velocities and using gravity assist to go between the planets, you could have seen a lot more than 3. Why didn't it come earlier?
Well, maybe it did. The point is we had the capabilities of surveying the sky only over the past decade. That's why all interstellar objects were found over the past decade. And of course, it cannot be a phenomenon that is just now happening. It could have happened before. But if we didn't really monitor the sky with, the kind of equipment that we're now using, we didn't have the computers we currently have to process the data, then we would have missed it. The timing could also reflect an interest of an alien civilization in us, because we keep broadcasting our existence without being careful about it. And by now, over the past century, our signals went 100 light years. Now, if you ask, when did 3I Atlas enter the outskirts of the Oort cloud, the outer boundary of the solar system, at 100,000 times the Earth-Sun separation? That happened 8,000 years ago, if you take the measured speed of 3I Atlas. So it entered the outskirts of the solar system 8,000 years ago. That's when humans started documenting their history. And that's assuming that it came from far out. If it happened to have originated from 1,000 times the Earth-Sun separation, it would have taken 80 years. From 100 times the Earth-Sun separation, it would have taken 8 years. So it all depends on where it started the journey. And of course, if it's a natural object, if it's a comet, it could, as we discussed before, it could have started the journey, 7 or 10 billion years ago. Just for comparison, Oumuamua was almost at rest relative to the local frame of reference of the Milky Way galaxy, the local standard of rest when it entered the solar system. Solar system just bumped into it. That was an unusual fact, and it implies that with the same analysis that I did with my student, we found that if Oumuamua was a natural object that came from a star, it must have originated from a very young star that is only about 1 billion years old. 2I Borisov, the second interstellar object that was a comet, that one it was intermediate between Oumuamua and 3I Atlas in terms of its speed, and it could have originated from the population of stars that have the same age as the sun, about 5 billion years. So we got a sample of 3 different speeds, very different from each other. 3I Atlas is the fastest by a large margin. As far as I'm concerned, the fundamental question is, what is it? Why did it come in this very special trajectory? Because in general, interstellar objects like Oumuamua or 2I Borisov, they came at a large angle relative to the ecliptic plane of the planets. This one just came aligned with the ecliptic plane.
Yeah, that's strange that it would. Aligned with the ecliptic plane, even if just a few degrees off as it is, you're not going to see that very often. Yet there it is.
Well, 1 in 500 or several hundreds. And the point is, we didn't have several hundreds objects like 3I Atlas detected before we saw this one aligned. We just had this one aligned, and it's the fastest moving object, and it doesn't have a cometary tail, and it comes close to 3 inner planets. And so I just say, let's monitor it, let's pay attention to it.
Well, I think it'd be a wonderful idea because it's not just Juno. Juno literally is at the end of its life. They're going to deorbit it and dump it into Jupiter. Might as well reuse it if it can be reused. And I read Anna Paulina Luna's letter, and I thought, well, that's good. Advocate in Congress, right?
Right.
To look. But we also have Mars, and I wanted to get your views on what could we do with the existent probes that we have sitting at Mars, like MRO, yes, and gather other observations of 3I Atlas.
Yeah, so MRO has a large number of instruments, one of which is a 0.5 meter aperture camera, high rise. And I suggested to the team to actually look at 3I Atlas on October 3rd when it comes close to Mars. Hopefully they will do that. They were quite positive, but of course there are issues with the direction of that it comes in and the fact that it moves fast. And but they are on target. They are thinking about focusing on this object at that time. And we need to keep our eyes on the ball, just like basketball players say. It's not about what is written on social media. It's not about the audience, not about getting likes. It's about keeping our eyes on the ball. 3I Atlas.
Well, obviously, take a look. It's right there. Take a look. Use, especially when you have a bunch of instruments that are at end of their lifetime. Take a look.
Right.
Use them. And I suspect NASA will, because they tend to do things like that. To give them their fair share, their fair due, they do things like this. So it would not surprise me if they repurpose these, instruments, or at least take a look. But I want to ask you this: with Juno going from Jupiter, with its instrument package, what could we measure if we got close?
Well, we can measure energetic particles, we can measure magnetic fields, we can try to image the vicinity of the object depending on how close we get to. And I think altogether it will be a boon to NASA because of the public interest. So here is another important point. Some of the SETI people or other people in academia were criticizing and saying, oh, forget about Juno. It's not interesting. It doesn't have enough fuel. It will not succeed to give us any information. We should keep it on looking at Jupiter, and that's it. And this kind of dismissive approach.
Yeah, but it's only going to look at Jupiter for like 8 more days.
Yeah, but just to show you the state of mind of some of these people, they would rather not look. I find it really puzzling because the public, is extremely interested. Over the past 10 days, I had 250,000 people reading my essays on medium.com. 250,000 reading essays. These are not tweets. Okay. And there is a huge amount of interest. Every day I get hundreds of emails, many of them excited about observing 3i Atlas. This is an amazing opportunity to attract the public to science, to inspire young kids. And I see it everywhere. Like there is a carpenter that fixed our porch. He came to my wife and said, "What is Avi up to? What's the latest on 3i Atlas?" And I've never met him. So she asked me to come outside, and I gave him a copy of my book. I signed it, and he was taking a selfie and said, "Look, my hand is shaking. I can't believe that I'm standing next to you because I'm so excited about this object and I'm following everything you do about it." Another person said that he was with me on a Zoom call at a sports club in Santa Barbara. After he finished the conversation, someone came over and said, "You mentioned the name Avi. Is this Avi Loeb? I can't believe you were speaking to him." There are millions of people in Spanish-speaking countries that read translations of my essays on 3i Atlas. And, over the past week, every day, on average, I had about 6 to 8 television, radio, newspaper interviews. And I'm trying to communicate the excitement of science that, it's all based on evidence. We can address exciting questions. Many of those critics are missing the point. Some of them are people who, didn't publish a single scientific paper over the past decade. These are bloggers or YouTubers that criticize the discussion on a possible technological origin. And I published over the past month about a dozen scientific papers, and they haven't published a single paper over the past decade, yet they are attempting to save science. From whom? From the people who practice science. I'm in the trenches doing the scientific work. I also communicate it to the public because I think it's important. It might inspire young kids to become scientists if they realize that we can address fascinating questions that their parents wonder about using the scientific method. So we don't know for sure if something is a comet. We will find out by taking data. This kind of a message is an amazing message, that you cannot convey even if you put $10 billion into the Large Hadron Collider and claim that you detected a new particle. Because, okay, you detected a new particle, you're announcing it to the public after the fact. They don't follow the process, and they don't understand the implications, and it doesn't have implications to their private life. But if 3i Atlas happens to be a technological probe, it will change the life of everyone. It will change the future of science, the future of religion. I had a group of religious scholars that came to Harvard and wanted to meet with me. They belong to an organization called Christianity Today. And they asked me, if we find extraterrestrials, would it affect in any way our religious belief? And I said, well, I have 2 daughters. And when the second one was born, it didn't take away from my love to the first one. So imagining that God is like a parent that can attend only to one child is very limiting. You should be happy if there are many civilizations. If we have siblings, the only issue is if we have siblings, we might be jealous at one of them because that one is far more accomplished than we are. That happens. If you have brothers or sisters and they are more accomplished than you are, you might be jealous. But other than that, it's actually a testament to your parents that they have more than one child, to their ability to manage such, so it's...
Well, but when you all right, I am not a religious person, of course.
I can tell you that they accepted this answer. They were very happy.
Well, I just immediately thought, it's if there is such a thing, and I'm like Einstein, I think in terms of the God of Spinoza and things like that. However, by definition, it would be omnipotent. It would be omnipresent, omnipotent, omniscient.
No, but the fundamental question here, even if you adopt Spinoza's view that the universe is identified with nature, the question is, does nature include more than one species of intelligent beings, more than one civilization? Given that there are billions of Earth-Sun analogs, would there be an issue?
No.
Imagining concept, irrespective of which concept of God you have.
No, you would think.
Would it be a problem to imagine
if you're
that?
thinking in that framework, it can do anything. So so there you go. There's your answer. Is that it is omniscient, omnipresent.
Right.
It can handle anything.
Yeah. So that basically strengthened my argument that also, if you imagine it being active, God is actually caring about us. It can care also about siblings the way parents do, and for us to meet our siblings in the Milky Way galaxy would be very enriching because we can learn from them.
Unless you meet them and they have their own religion and they're saying no, Zeus and Hera were the that's if you run into a religious conflict with an alien civilization, that's not going to end well. I don't think it never did with humans.
Oh no, but that happens also. That happens also when you meet a sibling that shares your DNA that was separated from your family. There is always the risk that they obviously develop different views of life and so forth. And, that has to be discussed, obviously. And we always, we don't know if we see a technological spacecraft arriving into the solar system, and we don't know if their intentions are good or bad. And of course, the way to find out is to exchange a message or to get a better sense of what the technology includes. So if it's an object that is just passing through the solar system and moving out of it, and they just wanted to monitor whatever they see along the way, it's just like a car in a highway. You let it pass. You don't worry about the implications for your home. So it really depends on what it does. And, the fundamental perspective that I have is that we are not that important. That was the message that Galileo and Copernicus brought, that we are not at the center of the universe. And that may be also that we are not at the center of the intellectual center of the universe, that, they don't care about us. We just came to exist over the past few million years. They started their journey billions of years ago, before we existed. They're just passing by and trying to learn something. We can't fully understand it because they arrived at our backyard before we arrived at their backyard, so they're probably more advanced than we are, or had more time. And so, I'm just saying, let's just monitor what is happening on our cosmic street and in our backyard. Figure out whether we have an intelligent neighbor, not by assuming we know the answer in advance or making all kinds of intellectual gymnastics. Here I'm advocating exactly for the opposite of what is done in the context of string theory, where you have a conjecture that there are extra dimensions, but you can't really test it in the lab. Here, you make a conjecture that you can test by looking at the sky, and the only
go look at 3i Atlas.
Look at 3i Atlas. Look at other interstellar objects. The only obstacle to that would be skeptics who argue we don't need to look. We know the answer. It's a comet, and how dare you discuss something else?
Well, I can't do that, though. I have to, again, you mentioned the Copernican principle, and I have to adhere to that, in that I do not think I'm a unicorn. I do not think human civilization is a unicorn in the universe, and I don't really think that there's a way to be alone, basically. Yeah. I don't think that we can be.
That's exactly my view. I was invited by the Polish government a couple of years ago to give a lecture in celebration of
Copernicus,
450 years to the birth of Copernicus in his birth town, Torun, in Poland. And the title of my talk was The Next Copernican Revolution. It's exactly what you just said.
It's also the mediocrity principle. It's the same thing, that I do not assume that I can't assume that I am not part of a statistical population of like occurrences, like everything else in the universe is. So why would human civilization, technological civilization, be unique? I don't see how it could be. That does not speak to rarity. It may be rare, At any given time,
Right.
you have the time issue where you may not exist at the same time as the other civilization does, at least within close enough proximity. But that doesn't actually mean anything as far as exchanging interstellar trash. So
But
you
my,
can't.
my point,
The Tesla flying the ExoMusk that sent out the Tesla a million years ago that flies the solar system. Well, there it is. It has a much longer lifespan than any human. We don't know how long human civilization is going to last or how long alien civilizations last in general. But if they last millions of years, their trash is going to be everywhere. Their Pepsi bottles flying through the star system. Isn't that wild of an idea, really?
My point is that there is a common thread between everything I said, and that is that we need a sense of humility. So humility says we shouldn't pretend to know the answer in advance. We shouldn't pretend to be the adults in the room. We shouldn't pretend to be those who know which path to take, but we should explore different paths. If we can search for radio signals, but we should also search for packages in our mailbox. We can search for microbes, but we should also search for intelligent beings at the same time, because we don't know what is easier to detect. And that sense of humility is basically driven by curiosity, allowing yourself to be curious, not to assume that something is more likely than another. And the only way to find out the answer is by collecting data. That also argues for a sense of humility in terms of who declares to be an expert that tells everyone else what the answer is. The public is pretty much fed up with that notion where experts lecture in a conference room, at a press conference to the public what they need to know. Because very often what the experts are saying ends up after a while not being correct. And we see this culture of echo chambers in the way that funding occurs in science, where there are selection committees that are allocating funds based on echo chambers. They have friends that they allocate the funds to. They don't deviate from the beaten path because they want to get funded for whatever they do. And, that is a closed circle. You don't have oversight on where funding is going and how innovative the science is and whether, other paths are being explored. No, if the experts say this path should be studied, then we will all go in that path. And then if at the end of the day we don't find supersymmetry with the Large Hadron Collider, okay, we went in the wrong direction, but at least we know that we tried that. But then what about the other paths? What about other approaches to quantum gravity? What about other approaches to SETI, not just radio signals, electromagnetic signals, laser signals, but actually checking for objects that arrive close to Earth? What about that? Why not check that? And, we would never know that we are missing something unless we check it. And that requires a sense of humility, okay? It means that you shouldn't pretend to be the adult in the room. You should pretend to be the kid in the room that is exploring the universe with wonder, willing to learn something new. At the end of the day, if you look back at traditional religions, religion was all about telling people that there is a superhuman entity, and therefore, they are not the most powerful. And when Friedrich Nietzsche, said God is dead, and that was followed by a whole century and a half of modern science and technology. That's sense of hubris, that we humans are at the top of the food chain. That will very soon be violated by our own creation, artificial intelligence. Within decades from now, it may have superhuman capabilities, cognitive capabilities, and that will tell us that we are not at the top. It's actually a machine that we created that supersedes us. But even before that, it might be alien intelligence that is superior to human intelligence that we might find if we are only open-minded to that. In both cases, we will realize that we are not at the top of the food chain. Therefore, we should have a sense of humility, and that means that we should learn. And the best way to learn is from evidence, from data. But if you tell yourself, I don't need data, I know the answer, you will never learn that you were wrong.
I think and this comes from being a science fiction author, but I think the most fun idea is that if there is such a thing here, It's here to stop us from developing artificial intelligence that can escape the planet and threaten the galaxy.
Well,
You can't,
that,
we're here as a police maneuver. You can't develop that.
that's if they care about us. Frankly, my guess is that, for our own benefit, we should look for them to get inspiration and do better. We need better role models than we find in geopolitics. A better role model will come from another star, and that will be the benefit to us. It's not as if they need us. I think that they don't really care about us, and if they pass by, it's for another reason, and we need to learn from them. And therefore, again, with a sense of humility, and when Enrico Fermi asked in 1950, where is everybody? When he was sitting at lunch at Los Alamos discussing extraterrestrials, this question is a question that every lonely person asks. Where is everybody? Where is my partner? And what you tell a lonely person is, don't be so presumptuous. You are not that attractive. You need to go out. You need to look through the windows for neighbors. You need to go to dating sites. You need to be proactive. And, this is really, if you look at the scales of both time and space that the universe offers us, they are vast. And for us to imagine that we are the most significant creatures ever made, given that there are billions of Earth-Sun analogs in the Milky Way galaxy alone, and another trillion galaxies in the observable volume of the universe, and many more beyond the cosmic horizon, just to imagine that we play a central role is really, wishful thinking. I mean, I remember my daughters thinking that they are at the center of the universe, that they are the most significant thing, because back then, when they were infants, their training data set, you can think of them just as large language models. They have a training data set and their intelligence depends on that. So the training data set of babies is limited to their immediate environment. So when they were babies, they thought that the world centers on them because all they saw is our home and the attention that the parents, we gave them. And they thought they are the most important thing. When they grew up, they saw some houses from the windows of the home when they stood up and they noticed that. But they never imagined that those houses may have humans like them, kids like them that deserve as much attention. The shock came on the first day in the kindergarten when they saw plenty of kids like them, some of which are more talented. And we as a civilization and also, members of academia have not matured in the perspective we have. We still argue that we might be, the only thing, and the universe is really, that's a rare occurrence, and the universe is really all about us figuring it out, just the way my daughters were when they were infants. And I just say, it might not be the case given the number of statistics. Let's be humble. Let's have some sense of cosmic modesty. Explore the universe with curiosity instead of being dogmatic. The best way to tell the difference between a dogmatist or a conspiracy theorist and a real scientist is to give all of them a lot of data. The conspiracy theorist or the dogmatist will be very worried about that, because whatever data you give them or evidence may violate what they believe in. A genuine scientist will be extremely happy. The more data, the better, even if it goes against what the scientists thought before, because it's a learning experience. We learn from the data, we learn from the evidence. We know throughout the history of science that we were wrong. Very often, the mainstream was wrong. And just think about quantum mechanics itself. Nobody expected that. Nobody ordered that. It was a complete surprise that the physical reality behaves in ways that are not deterministic. That quantum systems show entanglement, spooky action at a distance, according to Einstein. He himself had an issue with that. It was not at all clear how to interpret that, not to speak about nobody expected that to start with. And what does it tell us? It tells us that if you establish a research narrative where in advance what you're trying to discover, then you will not discover anything. Why? Because whatever is defined as a major discovery is something that was not expected. And so you should have a sense of humility and fund different paths towards the truth. And moreover, allow yourself to learn something that goes against your dogma or paradigm. Allow an object that enters the solar system to be anything. It doesn't need to be a comet. Let's see what the data tells us.
And let's collect the data. Now, I have two final questions, but I have to throw an observation out. If you run into an alien intelligence, a superintelligence that isn't biological, it may, again, to hammer this home, it may just be here because we're developing artificial intelligence. We may not be important, but the artificial intelligence is. And all of a sudden, we end up with the alien intelligence running off with ChatGPT off into the universe.
Right.
And everybody, human civilization is like, that was it.
No, that's a very good insight. In fact, Martin Buber, a philosopher, used to be at Princeton University a century ago. He came up with three types of interactions back then, a century ago. One was the interaction of humans with objects, the interaction of humans with humans, and he was religious, so he had also the interaction of humans with God. But obviously, there were no computers back then and no artificial intelligence systems available. And what we are confronting right now is additional interactions, human AI interactions and AI interactions. Just think about how fast will AI accelerate if it were to correct itself and interact with other AI systems without the human in the loop. Finally, there is human-made AI interacting with alien-made AI. By the way, alien intelligence is also AI, so we should not abbreviate it. And of course, it might well be if both of them are based on silicon, the human-made AI and the alien AI are based on silicon, they might feel kinship to each other more than they do to humans who are made of flesh and blood. And as you say, now, it could, in principle, help us. Our own AI could help us decode whatever messages we get from a visit, because maybe our brain is not capable enough to figure it out. And it's just like the Enigma code during the Second World War that was figured out by Alan Turing's team using computers. I mean, in principle, it may well be that we will need a superhuman AI that we produce to help us in figuring out alien AI.
If they could, because I bet you. Now, figuring out the Enigma code, that was one thing. Figuring out the U.S. code, nobody ever did, because we were basing it on languages, Navajo, that were not connected to any other human languages that are extant. And at some point, that gets almost impossible to figure out if you don't have the key. And we just so happen to have the key. But I don't think that code was ever broken, right?
Yeah, so code breaking is an art that in the future might be dominated by quantum computers that operate very differently than traditional computers. And of course, the question is, what do the aliens use and how complex is their language? And, that's a very rich subject. And when we have an encounter with a functional device, that will open up new avenues of research. My hope is it will also inspire us if we realize that they traveled all the way to our home planet, and and we have all kinds of potential existential risks on Earth, then we should send a space platform with humans on it for a long journey as well to other places. And that's not a simple task, but I see it as a much more inspiring task than going to Mars. Why? Because Mars is just another rock that happens to be close to Earth, doesn't have an atmosphere, has dust storms, the temperature on the surface changes by hundreds of degrees, you're not protected from cosmic rays. You might not be able to survive unless you go underground into a cave. What I'm saying is going from Earth to Mars, as much as it sounds very ambitious and visionary, is just like, being born in the jungle on a given tree and saying, oh, look at the distance, there is another tree where there might be more, we might go there. We don't know if something bad happens to our tree, maybe we should occupy that other tree as well. So going from Earth to another rock is very similar to that. But the point is that it doesn't really solve the long-term problem. And, we went out of the jungle into today, after a few million years, we are occupying high rises in cities all around the world. And the transition from trees in the jungle to high rises in cities is a major transformation, very different habitat, because in the city you get everything you need. And, going from the high rise of a modern city to space sounds to me like less of a leap compared to the transition from a tree to a high rise. And I do think that in the long-term future, we should contemplate a detailed plan for building habitats in space, a space platform, not just like the space station, but actually a place where people can live long-term, that can travel distances. That, to me, sounds far more appealing than imagining a rocket, a giant rocket that will bring humans to Mars, because once they get there, I would argue it's a much more challenging environment, less hospitable to life. What's the point of bringing people on a one-way trip where they would die soon afterwards from all kinds of risks? We really want to be smarter than that and establish something like Noah's spaceship. Noah built an ark to save animals from the great flood. And in my book, I refer to Noah's spaceship, and I wrote the book Interstellar where I talk about it. That will be the equivalent of Noah's ark, except it will save representatives of humanity in space and perhaps interstellar space. Now, I'm talking about doing that in the future, but the sun formed in the last 1/3 of cosmic history 4.5 billion years ago. And that's exactly 1/3 of the age of the universe. So we are late to the party. Most of the stars formed billions of years before the sun. We can see them in the Milky Way galaxy. We can date them. We know that most stars like the sun formed billions of years before the sun. And that means that, the party was going on before we arrived. As a result, other civilizations might have lived billions of years ago. Where is everybody? Well, if you ask this question about humans on Earth, there were 100 billion humans on Earth, over the past few million years. Most of them are dead. Right now, we have only 8 billion that are alive. The rest are dead. The same may be true of other civilizations. Not only they existed billions of years before us, but they managed to die by now. However, some of them might still be alive, those that sent representatives to interstellar space. If we want to leave something behind, that will maintain the guidelines of the human civilization, that would represent us, we better aspire to build space platforms that would carry humans, and not just to the immediate vicinity of Earth, not just to another rock like Mars, but actually go interstellar with many generations of people on the ship.
Well, the idea, and this is actually the Jeff Bezos vision, but it goes back before that. His professor was Gerard K. O'Neill, and O'Neill cylinders and things like that, where people could live on giant O'Neill cylinders, and you could send those interstellar. I mean, it's possible to make a generational ship.
Yeah. So here is my question: could it be that 3I Atlas is one of them?
No, maybe.
In Rendezvous with Rama, the size of Rama,
yeah,
in Arthur C. Clarke's science fiction novel,
very good novel.
The size was, it was a cylinder, and the diameter was 20 kilometers. The length was about 50 kilometers. That's not very far from the inferred size of.
Well, depending on inferred size with 3I Atlas, that's a big question. But the question is, did you read the novel and did you like it? Rendezvous with Rama.
I didn't read the novel. I actually learned about it after I wrote my paper on Oumuamua, and people noted that I should check it out. Now, I don't like science fiction, because very often the storyline deviates from the known laws of physics. I enjoy doing science where, I follow the laws of physics as we know them, and I guide my imagination based on that. But I have a problem when someone talks about things that I know we have no evidence for. So
Well, also no ability, because then that becomes fantasy. But good hard science fiction, like Arthur C. Clarke, was pretty good at that.
yeah,
Where it's like, yeah, there's some plausibility there.
no,
Maybe not
he,
entirely,
he
but
was definitely very visionary and wise. And I would much rather learn from a first-class science fiction writer than from a second-class scientist.
now my last question for you, Dr. Loeb, is this. The Galileo project, you have a new observatory coming online. Tell us about that.
Yes, so over the past 4 years, we designed framework of an observatory that monitors the entire sky at all times in the infrared, visible light, radio, and audio. And that's very different from astronomical observatories that are usually focused on a small portion of the sky at any given time. And the reason is that we want to check any objects within the Earth's atmosphere that are flying very fast across the sky. We want to find out if all of them are familiar, all of them are human-made, such as drones, balloons, airplanes, helicopters, satellites, or natural, like birds. Check whether there are any outliers. For that purpose, we need to identify the distance of each object that our cameras are recording. That capability will be available to us within a month because we will put multiple units within each observatory that look at the same object in the sky from different directions. It's just like the method of parallax or triangulation, and the reason that we have two eyes, by the way, is to protect ourselves from predators that might be very close to us. We can triangulate and figure out their distance and the level of threat. And so the Galileo project will use multiple units like that, hopefully within a month, and we will start getting distances. As of now, without distances, we can see a few million objects every year. Out of those, without distances, we can identify 97% of them as being human-made or natural, using artificial intelligence software, machine learning software that is trained on familiar objects. And of course, as we get more data, this software will become more efficient. But the distances are really essential for figuring out the velocity or the acceleration of objects so that we can check if it's within the performance envelopes of familiar objects, human-made or natural. And so that capability will change everything because then we can get to an object-by-object analysis, look for outliers that are really beyond what we can imagine based on what we are familiar with. And I really look forward to seeing if there are any such objects because the Director of Intelligence delivered 3 reports to the US Congress about unidentified anomalous phenomena. And I was invited on May 1st, 2025, to give a briefing about the Galileo project to Congress, and I was informing them about what we are doing with the Galileo project, and I really hope that in the coming months we'll be able to say something statistically about whether there are any anomalous objects. And we are finishing the construction of 3 observatories. One already exists in Massachusetts at Harvard University, another one in Pennsylvania, and a third one in Nevada. We will operate all of those and see what comes along. The Galileo project also has a branch that attempts to retrieve materials from interstellar meteors. These are objects that happen to collide with Earth at a speed that indicates that they came from outside the solar system. And there was one such object reported in 2014 by the US government satellites, and the data appeared in a catalog of NASA, and we arranged an expedition to the Pacific Ocean to look for the materials. We analyzed the materials that we retrieved and found some unusual chemical composition for about 10% of those molten droplets that we retrieved. And there will be a Netflix documentary that will show how this expedition went and the research within the Galileo project related to that, coming out in early 2026. that would allow the public, again, to be excited, interested in science that is evidence-based. And finally, one of the most recent research avenues that we are pursuing is getting access to data that will come from the Rubin Observatory, searching for interstellar objects that may be of technological origin. And so altogether, we want to find if there is any evidence for extraterrestrial artifacts near Earth that could inform us about a cosmic neighbor, just like finding a tennis ball from another neighbor in our backyard.
It's all fun and games until the tennis ball hits you. Now, Dr. Loeb, thank you for joining us today. And everybody should check out Dr. Loeb's books, which are available everywhere, Interstellar and Extraterrestrial, and interesting ideas and something to keep in mind for sure. Dr. Loeb, do you realize you were the very first guest on this show many years ago now? I believe 8, something like that.
Well, that's a testimony to your open-mindedness, and you've done a terrific job communicating science. And I really, I was asked on a podcast a few months ago, how do I want to be remembered? And I said, based on my future work, because the best is yet to come.
My thinking is that I don't want to be remembered. What I want to be remembered are the interviews I'm doing. So I always lamented that there weren't enough interviews done with Einstein. There are very few. And I mean, you can find them on YouTube.
By the way,
what I'm trying to do is document the people that actually are smart in this world, above and beyond.
And that's important for another reason, because once you have a lot of interviews, you can, in principle, train an AI system on that data set so that even after the person dies, it could sort of provide us with an avatar, something similar that would answer questions that arise in the future based on the way that this person behaved, thought, and reasoned.
That is the future. That's the reality of the future.
So let's hope that this interview will be fed into an AI system long after I die, and that there will be something representing me online that you can speak with even after I'm not around.
Let's just hope it's accurate and it doesn't have motives of its own to twist the information. Thank you, Dr. Loeb.
Thanks for having me.
Event Horizon and my channel are now available as a podcast on Apple Podcasts, Spotify, and YouTube memberships. Early ad-free episodes, bonus episodes, and sleep-focused content. Sign up now by clicking the links below to your platform of choice.